topic of this video is limit at infinity for functions involving radicals or radical functions. So we should remember from the pre-calculus we have talked about absolute value of x. Absolute value of x is a piecewise defined function. It is equal to x if x is greater than or equal to 0. It's equal to negative x if x is less than 0. So we have talked about when x is any real number, when x can be any real number, and we're pulling out an odd power from an even root, we must put the absolute value bars. The reason why we do that is because there's two ways of writing square root of 64. We can write it as 8 to the second power, and we can divide the index with the exponent and get the 8 out, or we can also write it with negative 8 to the second power and get the negative 8 out. And these two are not equal to each other. So we want to make sure the square root of an even number is square root of an even root is always, or any even root is positive only. It's not positive and negative both. So square root of 64 is only 8, not plus and minus 8, okay? So that's why we want to make sure if we pull out an odd power from an even root, we must put the absolute value bars. Only need to worry about the even root. We don't have to worry about the odd roots because in case of odd roots, cube root of 64 can be only written in one way, which is 4 to the third power, and 4 comes out. It cannot be written as negative 4 to the third power because negative 4 to the third power does not give me 64. It actually gives me negative 64. And cube root of negative 64 is negative 4. So no need to worry about when you're dealing with an odd root, but anytime you are taking out an odd power from an even root, we need to put the absolute value bars to make sure the answer is positive only, because answer to an even root is never negative. So square root of x squared, I'm going to pull out x to the first power, odd power out from an even root, so absolute value of x. X to the third power, yes, I do need the absolute value of x, because we can divide the exponent with the index. 6 divided by 2 is 3. And if I divide 2 with the 2, I get a 1. X to the 10th power. So I would be able to get x to the 5th power out. I do need the absolute value bars. X to the 4th power, x squared comes out. No need to put the absolute value bars because no matter what x is, even if it's negative, when I'm going to square it, it is going to become positive. X to the 12th power, x to the 6th power comes out. Again, no need to put the absolute value bars. This is the problem number. No need to put the absolute value bars because even if x is a negative number, when I'm going to raise it to the 6th power, it's going to become positive. Remember to use absolute value only when we bring odd power out from an even root. So here's an example. Find the end behavior of the function. So here we have the highest power in the denominator is square root of x to the 6th. It's very important to realize square root of x to the power 6th is absolute value of x to the third, which is going to equal x to the third power if x is greater than or equal to 0, and negative x to the third power if x is less than 0. So I'm first evaluating limit to the negative infinity. That's going to be the left end behavior because I'm looking at what is happening to the y values when I go far, far, far to the left. So I'm going to divide both numerator and denominator with 1 over x to the 6th square root. In the denominator, I'm just going to take x to the 6th square root inside the square root. So limit x goes to infinity. In the denominator, I would be just write as 25x to the 6th over x to the 6th plus x to the 4th over x to the 6th plus 2 over x to the 6th. In the numerator, when x goes to negative infinity, square root of x to the 6th is equal to absolute value of x to the third, and it is equal to negative x to the third. So keep that in mind. When x goes to negative infinity, that means x is less than 0. So we're going to replace square root of x to the 6th by negative x to the third. So 10x to the third over negative x to the third minus 3x squared over negative x to the third plus 8 over negative x to the third. And let's see where does it take me. Limit x goes to negative infinity. That's what we had in the problem. Negative infinity. So this turns out to be negative 10 plus 3 over x minus 8 over x to the third divided by 25 plus 1 over x squared plus 2 over x to the 6th. Okay, now when x goes to negative infinity, when x gets really large negative number, 3 divided by a very large negative number goes to 0. 8 divided by a very large negative number goes to 0. 1 divided by a very large negative number, and 2 over a really large number, all of those go to 0. And all we're left with is x goes to negative infinity, negative 10 over square root of 25, which is negative 10 over 5, and that turns out to be negative 2. So horizontal asymptote is y equals negative 2, and we can say this limit is equal to negative 2. Now we are about to evaluate the right-hand behavior. For the right-hand behavior, we need to keep in mind, because x is greater than 0, we're going to be using square root of x to the 6th is equal to x to the 3rd, positive x to the 3rd. So same thing, divide numerator and denominator with 1 over square root of x to the 6th. x to the 6th plus x to the 4th plus 2. Okay, so now I'm going to take x to the 6th inside the radical in the denominator and simplify to x to the 3rd and divide that in the numerator. X to the 3rd plus 8 over x to the 3rd. Divided by square root of 25x to the 6th over x to the 6th plus x to the 4 over x to the 6th plus 2 over x to the 6th. Let's go ahead and simplify. This can be gone. Limit x approaches positive infinity, not 0. We're looking at positive infinity here. X goes to positive infinity. So we have 10 minus 3 over x plus 8 over x to the 3rd divided by square root of 25 plus 1 over x squared plus 2 over x to the 6th. Now, all these terms will go to 0. Because when you're dividing a small number with a very large number, it's going to go to 0. So limit x goes to infinity, 10 over square root of 25, it is equal to 2, 10 over 5. So y is equal to 2 is also a horizontal asymptote. And we can say this limit is equal to positive 2. This limit is equal to positive 2. Here's what, were there any horizontal asymptotes? Yes, there were 2 horizontal asymptotes for this problem. Y equals positive 2 and y equals negative 2. 2 horizontal asymptotes. Next, we are going to look for the horizontal asymptote for e to the power x over 1 plus e to the power x. So in this case, think about this is e to the power x. Horizontal asymptote means we're looking at limit x goes to infinity and x goes to negative infinity, right? So when limit x goes to positive infinity, we have e to the power x, 1 plus 1 over e to the power x. When x goes to infinity, this is like e to the power infinity, 1 plus 1 over e to the power infinity, which is e to the power infinity 1 plus 0, because 1 over a really large number is going to be 0, and that's going to go to infinity, right? That's going to go to infinity because this term goes to 0, and e to the power infinity is very large. It's going to be infinity. Now I'm going to evaluate limit x goes to negative infinity for this function. So e to the power x over 1 plus e to the power negative x. When x goes to negative infinity, this goes negative infinity. 1 plus e to the power negative times negative will be positive. So this becomes 1 over e to the power infinity divided by 1 over 1 plus 1. So that's going to be 1 over 1 over okay, let me change this a little. So this is going to be 1 over e to the power negative infinity. 1 over e to the power infinity is going to go to 0. So on the top, I have 0 divided by some number, and that's still going to be 0. So this function is going to go to 0. Here, I could have, instead of writing it this way, I could think of it 1 plus 1 over e to the power negative infinity. So 1 over a really large number, that would be also 0. So 0 over 1 plus 0, and that's going to equal 0. Next, we have square root of 36x squared plus 7 in the numerator and 9x plus 4. So if you have a radical in the numerator, then we would go ahead and divide. So we need to evaluate both limit x approaches positive infinity and limit x approaches negative infinity. 36x squared plus 7 over 9x plus 4. So I'm going to divide both numerator and denominator with, we need to keep in mind square root of x squared is equal to absolute value of x, which is equal to x if x is greater than equal to 0. It's negative x if x is less than 0. Keep that in mind. It's very, very important. So limit x goes to infinity. Because I have a radical in the numerator, I'm going to go ahead and divide both numerator and denominator with 1 over square root of x squared. All right, so let's see. Now I'm gonna take the square root of x squared inside the numerator. In the denominator, the square root of x squared is going to equal positive x. Square root of x squared is going to equal positive x because x is going to positive infinity and the x is greater than 0. So this would be 9x over x plus 4 over x. Let's go ahead and simplify now. So in the numerator, x squared and x is gone. And this leaves me with limit x goes to positive infinity, square root of 36 maybe brighter color, square root of 36 plus 7 over x squared divided by 9 plus 4 over x. When x gets really, really large, this term goes to 0 and this term also goes to 0. So we are left with square root of 36 over 9, which is 6 over 9, and that's 2/3. So that is my horizontal asymptote. Horizontal asymptote y is equal to 2/3, or we can say this limit is equal to 2/3. Now I also need to evaluate, because I was asked to look for the horizontal asymptotes, I also need to look at negative infinity. What is happening when x goes to negative infinity? So I'm going to go ahead and change this problem. Maybe I can use red color now and change this problem. So x goes to negative infinity. What happens when x goes to negative infinity? When x goes to negative infinity, square root of x squared is going to equal to absolute value of x, and it is going to equal to negative x. So that's going to be one change we see here, and that's going to make it negative 9, and that's going to make my answer negative 2/3. So I didn't have space to do the whole thing again, but if you are doing this problem for the homework, do it twice, once looking at the negative infinity, once looking at the positive infinity. So there's two horizontal asymptotes here. Y is equal to 2/3 and y is equal to negative 2/3. Those are my two horizontal asymptotes. Next, we have a radical function. We're going to look at, now this function involves radical, but it doesn't have anything in the denominator. So I'm going to start by rationalizing this function. Limit x goes to infinity, 2 root x minus square root of x plus 2. Times 2 root x plus square root of x plus 2 divided by 2 root x plus square root of x plus 2. Okay, this is 1 in the denominator. So I'm rationalizing the numerator. This is going to leave me with 4x minus x minus 2, because I would have to distribute the negative inside the radical, or you can write it like this for now. And in the denominator, I have 2 root x plus square root of x plus 2. Okay, limit x goes to infinity, 4x minus 2 over 2 root x plus square root of x plus 2. So now the highest power that appears in the denominator is square root of x. And I'm going to go ahead and divide both numerator and denominator with that highest power that appears in the denominator. So divide both numerator and denominator with square root of x. So limit x goes to infinity, 1 over square root of x, 3x minus 2, divided by 2 root x over root x plus 2 over root x. Only thing we need now is a little simplification. Limit x goes to positive infinity. So we have 3x over root x minus 2 over root x divided by 2 plus root x plus 2. We can split it into square root of 1 plus 2 over root x. A little more cleaning up, simplification, and we are really close to be done. X divided by square root of x would be x to the power 1/2. If we subtract the exponents, 2 over root x divided by 2 plus 1 plus 2 over root x. Okay, now when x goes to infinity, this term goes to 0. This term also goes to 0. But where does this term go when x goes to infinity? This term is going to go to infinity. So horizontal asymptote in this case, we don't have any horizontal asymptote. The y goes to infinity when x goes to infinity. Okay, y goes to infinity when x goes to infinity. There is no horizontal asymptote in this case.